Okay, folks, here is our video for today. Just making sure my focus locks in. Hang on. Focus. There we go. Okay, so as a real quick review, here's what we've learned and where we're going. A limit is just a value you approach. I'm going to change those words. It's a y value you approach as you get close to a certain x value. And we've done this two ways so far. We've done it graphically, which is the easiest way. For this function, the limit as x approaches 2 of f of x, the height of the graph is 5, but the value at 2 is undefined. There's no actual value of the graph there, but the graph heads towards 5 as x approaches 2. And the other way we did it was algebraically. If we want to find the limit of this as x approached 2, I'd fill in 2 and I get 0 over 0, which is indeterminate. Whenever we get that answer, we know there really is an answer. I'd use synthetic substitution, and I would factor it, which I'm doing right now. And so the limit now, I can cancel things out. So x approaches 2 equals 4. Okay, so the stuff with limits, the approaching the values, we're going to leave that behind for a little bit, and then we're going to pull it back in soon. So this seems like a different topic, and it kind of is right now. We're going to talk about slope. Slope is... Oh, we get a better pen here. Let's go with purple. Slope is what we've been talking about, and slope is just the rate of change. It's another word for rate of change. And the slope can be defined by a tangent line, meaning if I drew a picture of any curve, the slope at any point is the slope of the tangent line at a point. I'll draw a point here. Whoop. I'll draw a point here. Whoop. I will tell you that the slope... Let me draw one more. Let's go here. So those are three little tangent lines. I know right here that the slope, or the rate of change, is positive because the line is going uphill. I know here the rate of change is also positive because the slope is going uphill. And I know here the rate of change is negative because the slope is going downhill. So first what we're looking at is graphically. In fact, I'm going to draw one more picture. And if you were to guess, what do you think the slope is, or the rate of change, at this point right here? Well, I'll draw a tangent line. And how much slope does it look like it has? It looks like it has none. Oh, zoom up a little bit. So the rate of change right here is 0 when it has a flat tangent line. So that's graphically how slopes and rate of change works. Algebraically, there's two types of slopes we're looking for. Average slope, which is the slope between 2 points, and instantaneous slope, which is the slope at 1 point. So if I was going to kind of connect what I've done so far, all these pictures over here are instantaneous slope. They are slope at exactly 1 point. I can't tell them exactly, except for this one right here I can, but I'm kind of estimating them by drawing a tangent line. So instantaneous slope is known as a tangent line. And the goal is to be able to figure those out. For right now, all we can figure out is average slope. And there's three formulas for that. They're all the same thing. Change in y over change in x. Or some might call it rise over run. Or some might call it 2 minus y1 over x minus x1. They all mean the exact same thing. Or the one that I'm going to use a bunch is called fib fa ba. So the reason I'm going to use this one the most is these ones right here work really well off of graphs. And these work really well with numbers. and we want to try not to mix things up. So either one of those is going to be fine. You're always going to have 2 points to do this. There's no way around it. An example of a problem, algebraically, would be the following. Let's say that f of x equals x squared, and it asks me to find average slope. So as soon as we hit the average, it's going to be 2 points between x equals 1 and x equals 3. So really quick, if I were to graph what that would look like, I'll draw a small picture here. Here's y equals x squared. Here's x equals 1. Here's x equals 3. It'd be the slope of this line right here, which would be the same as rise over run. So what I'm going to do is I'm going to use my fib-faba formula. So it's equal to slope is equal to, doesn't matter the order I put these in as long as they stay consistent. I'm going to go 3 minus 1 over f of 3 minus f of 1. Hence my fib-faba. The b and a appear on the bottom, and the 3 and 1 are going to go in. Now I put those into the function, and I will get 9, because 3 squared is 9, minus 1 over 3 minus 1 is 2. Equals 8 over 2. So that equals 4. So that means the slope of this line, this average slope right here, would be 4. And that makes sense. It's positive. And it looks like a positive number right there. So I kind of covered a bunch of things in this little section right here. The quick review of it, the limit is the stuff we've done in the past. We're not using it right yet, but we're going to come back to it. And in the end slope, there's 2 things we need to know about. There's average slope, which involves 2 points. There's instantaneous slope, which involves 1 point. Right now, we don't know exactly how to find instantaneous slope. We can guess at it, unless it's a perfect flat curve. But we can always find average slope. If we're given 2 points, we just put those 2 points into the function. Put the x values on the bottom, put the y values on top, and simplify it out. And we go from there. Okay, so let's take a look. I'll send this in a picture in a little bit. Let's take a look at the notes from yesterday. I'm going to move this page over. And I'm going to look at the picture I came with yesterday, which is page 2 of the notes right here. And you'll see I have a picture of a seagull flying through the air. Time is on the x-axis. It'd pretty much always be. And height of the bird above the ground is on the y-axis. So if I were to describe, I'll fill these in 5, 10, 15, 20. If I was going to give a verbal story about my seagull, first my seagull, as time went by, started flying up and up and up and up and up and up and up in the air. He thought he saw some food on the ground, so he took a little dip. He started heading down, realized it wasn't going to be good, and then he flew back up in the air again as time went on and on and on. So the first thing it asks is, what is the bird's height at t equals 0? So what's the height of the graph at time 0? Well, it doesn't look like there's any height. As a matter of fact, it is 0. Why? Because the bird is on the ground. As a matter of fact, the bird is on the ground for the first 1 second. We can tell because the height of the graph for that whole first second is 0. What is the bird's height at time equals 2? At time equals 2, I'll put a dot there. The bird's height is 20. Let's put this in feet. I'll write feet on here. The bird's height is 20 feet. What is the average rate of change between time 1 and time 2? That means they're asking me for rate of change, which is slope, which is fib-faba. I'll put or y2 minus y1 over x2 minus x1. I'll always deal with the x's first. Between times 1 and 2, I'll put the 2 here, and I'll put the 1 there. The y value that goes with the 2 is 20. The y value that goes with the 1 is 5. Put in my minus signs. I get 15 over 1. 15 is the average rate of change. And I can actually tell you what the unit measure are. Rates are measured with pers. The units of measure here are feet per second, which makes sense. It's feet per second. That's where I find those values on the graph. What times does the bird change direction? Well, it looks to me like the bird changes direction. He starts, instead of going up, he starts going down at like 3.1. And again, he starts going back 4, 5 point. It's going back up again at 5.5. We can see that change in direction. It looks like it's here. It looks like it's here. What is the bird's velocity at those times? It's asking for instantaneous velocity. and the instantaneous velocity, I'll just draw a tangent line. And you can't always tell what's going on in a tangent line, but you can kind of tell. The slope is how much that thing is tipping. The slope of that tangent line is 0. So the bird's velocity, which is its slope, is 0 at that time. And it kind of makes sense if you think about it. The bird's flying up and up and up and up and up and up and up. And ultimately he gets to the highest point he's going to get to. Once he gets to the highest point, he has to turn around. So his slopes are all positive, but then they flatten out, and then he starts going in the negative direction. Which feature on the graph shows this bird's velocity? It's the tangent to the point. Tangent to the curve at the point, but I'll put tangent to the point. So instantaneous rock equals slope. Graphically, it's a tangent line. And they want me to estimate the velocity at 2, which I'll draw a line here. I'll get a different color for this one. I'll estimate it at 4. I'll estimate it at 5 point. I'm going to change my answer from before. 5.8. Which will be there. 7's easy, it's 0. I know the one at 2 is positive. And I know the one at 4 is negative because it's going down. Now there's a bunch of ways you can do this. You can draw a full triangle and count the rise over run. That's what I'm going to do here on this one because it's easy to do. So went up 5, 10, went up 15. It went over 2, so I'm guessing 7.5. Look at the other tangent line here. I don't know. It's hard to see. So what I'm going to do is I'm going to estimate. Just, a slope down at 45 degrees is equal to a slope of -1. I'm going to estimate this slope at -1. Let's go for it. Doesn't have to be accurate. The only thing I care about is the signs right now are correct. Okay, so what did we do here? We took a picture of displacement. We drew some tangent lines on and estimated their slopes. And we also found some average slopes by using 2 points. The easiest thing to do is always use average slope because you can find the 2 points and fill them on in. Okay, let's see what's coming up next. Pause it for a second. Okay, so we looked at graphically how to find the instantaneous slope. Just draw the tangent line and see if you can get it right. But now we're going to look to find the instantaneous slope algebraically. So how do we find average slope? Average slope is fib faba. So we use just 2 points. How long is an instant? It is infinitely small. It's so small, no time actually passes. But I'd like to find instantaneous slope. I'd like to find instantaneous slope at a point. So I'm going to take a chance. I'm going to use fib faba. I'm going to try fib faba using 1 point to see what happens when I fill this in. So if I want to find the slope exactly at x equals 2, I'll put 2 on the bottom here, but I also use 2 as my other point. I'll fill in f of 2. Well, f of 2 was 20 minus 20 over 2 minus 2, which is 0 over 0, which we've gotten before, which is indeterminate. Well, what's the problem? The answer does not any info. Indeterminate means we don't know what's going on. So using 1 point in the fib faba formula, in the average slope formula, even in y2 minus y1, it would be the same thing. It would be 0 over 0. Doesn't give me an answer. Okay, so what we're going to do is right now we're going to dump trying to find instantaneous slope exactly. We're not going to find it exactly. We're going to try to estimate it first. We're going to try to estimate average slope. Okay, so here is your job for the rest of the time today. You're going to try to come into class with this information filled on, and I'll help you with a little bit of it. Okay, we're going to try to estimate the slope at x equals 2. The way we're going to do that is we're going to pick a point, 2. So A will be 2. And we're going to pick a point just a little teeny bit past that. As a matter of fact, let's go with... Actually, I'm going to change the way we do this. We're going to do this part together, and I'll show you what you're going to fill in. We're going to go with 2.1. So as I've taken my B, I've gotten 2.1. So I've got a point that's just a teeny bit away from there. So now I'm going to use 2 and 2.1 and find the average slope, and it should be close to what the slope is at 2. So to find average slope, delta x just means how much these things have changed. It's just another way of saying this is going to be 0.1 because I'm using 2 and 2.1. To find the average slope, I'm going to fill it in a 2. I'm going to fill in a 2.1. Oop, nope, that's 2.1 here, and a 2 here, 2.1, and 2. And for you guys, you're going to finish filling in this box for me. You can do it on regular paper, and the way you're going to do it is you can put those two numbers, the 2, into this function. You're going to put the 2.1 into this function, and it's going to give you an average slope over the interval 2 to 2.1. I'm going to fill it in there. So what I'm going to do is this chart's going to be too much work for us right here. And you can talk with each other on how you're going to do this particular problem. So we're going to do one more like this. I'll put it on this page so I can take a picture and send it to you. I'm going to go to the bottom. I'm going to go right to here. And I'm going to, so we made this interval 0.1 unit long. I'm going to have you do it again. I'm going to have you make A equal to 2. And I'm going to have you have B equal to 2.01. And then you're going to run fib-faba. And you're going to get an answer for what that fib-faba estimates the slope to be. So just to reiterate again, you're going to finish this problem right here by filling in 2.1 and 2, putting them, finding their values, and then finding the answer to what the average slope is between 2 and 2.1. And you're going to put that number here, and you will text me that number that you get. And the way you'll text it, you write average 2 to 2.1 equals, and you'll send me an answer. And then for this other problem we have right here, you're going to do the same thing. You're going to find A at 2, B at 2.01, fill in fib-faba, get an answer, and then you will text to me average 2 to 2.01, and you will send me an answer. And we will pick up from there. Okay, so that's your work for today. This shouldn't take you too long with the calculator. If you have questions on it, you can send me the picture. I will send out these notes that I made in just a minute. Please remember the only thing you're doing today is that you're working on your own, is we're using average slope by using 2 points in this formula. And here's an idea of what the instantaneous slope would be close to, because we're making the interval really small. That's all the new work you're doing. Okay, video on its way up. Way soon. Take care.